But what does that tell you about the order of hydrogen with the order of the reaction with respect to hydrogen? Yes.
The first order.
Order number 1. Nizo. Tinato ile tupa statement itoto. Tatina. Tatina. If I double then it doubles. That's order number 1. And it? Yes. What is the second statement? Order number 2 chichinoitic. Factor of 4. So if I double it quadruples, isn't it? You need this statement. Sometimes you don't need to, or you can, what about the calculation? Parallel to the calculation calculation. Karimuna Manoing. Kausha have Tiba. It's about what happened to the rate after I changed my concentration. You can also use this one. For example, I said factor of 4. What happened here? I can divide these numbers and see what happens. And did you try everything else? Could you try after these two? What try around 1 and 3, around 1 and 4? I don't think it's necessary in this case. And when we double the concentration, the rate also double. So we can conclude from that. And okay, I guess if it's about order, then that's our answer. And we want to do the calculation. According to the calculation, did you get double? You open something else, something different. So you can calculate, or you can just figure out from these statements. And these statements are always true. And the statements are always true. You have a statement for your first order, a statement for second order. Order number 3, what difference? You have a statement for order number 3.
You calculate nayo concentration yaonengwa piwa yacho like anataka kwa hydrogen second volt concentration ya hydrogen
okay
yekta H2 inenge mazasi inenge adambuliwa yacho H2 ndio isa console vile the concentration ya hydrogen yekta so the formula to the power m.
What is m? M is order. Alright.
So, let's see the time. Yes, you can just improve.
R1 is what? 6 what?
R1 again.
6 times 10 to the power minus 7.
10 to the power minus 7. Divided by R2.
6 times 10 to the power minus
1.2 times 10 to the power minus 6. Is equals to concentration of hydrogen H2 2
times 10 to the power minus 3
times 10 to the power minus 3.
Pesa nicha. That's what pesa is. R2 is what pesa is about numbers.
Thank you.
R2 is 1.2 times 10 to the power minus 6. But we are doing the same thing, right? You figure out the factor by which your rate increases, the factor by which you change your concentration, or you equate, right?
The power m. So, pana batuno na mtikati.
Tunapata 2 is equal to 2 to the power m.
So I am my indices. To what that is as 2 to the power 1.
So what m is equal to 1. Those are the okay, so let's move on. Yeah, thank you. Correct. So if I were to surprise in a table, you just remember the score. What happens if I change my concentration? Right? If I double it, what happens to this? The relationship between concentration and rate, when mass. Right? So next question. Next question. It's in November 2018, paper 3. Okay, what's the question? You get it? Yes, go ahead. Anyone? November 2018, paper 3. It's on, what is it about? About what? Did you do Baba solutions? Kana sataita Baba solutions, what is a Baba? Part of my equations anoshandiswa to determine field of the Baba etc. Atina kuita atsata takasata zviri kumberi manje tonazo 20 minutes explain that. So unfortunately we need to go through everything. A buffer is a solution that resists changes in pH. Like your blood is a buffer. If the pH of blood changes, then the blood itself is equipped to resist any changes in pH. Drink a poison that's trying to change the pH of your body, it will not change significantly. So, for example, if this is a buffer and I add an acid, what do I expect? I expect my pH to what? Go up or down? Down. It's supposed to go down. So the idea is by I can say by what factor does it go down? You could change as value. So let's say it was a pH 8. How far down does it go? So buffers resist changes in pH. So it might change from 8 to 7.5, for example, after adding a lot of this. So it's a solution that resists that change. Likewise, if this was a buffer and you added a base, it's supposed to go up, but it does not increase significantly. The buffer is made by mixing what? Usually what? Salt of what? For example, an acid and a salt of that acid. So unfortunately, we then need to look at the assumptions and then the equations that we need to do. Let's save that for another day. Yes. And the password kite. And we'll do buffers in detail. Yes. Next question is about what? It's about what? Not necessarily a question, but a concept that you feel like I need clarification on this. It's about what? Standard electrode potentials. Good one. Yes. What about them? Our standard electrode potentials. Upon that data booklet. Anyone with the data booklet? Yes. So what's the question? Do you want us to explain what they are, how you use them, or you want us to do a question? It's a question, a specific question. Yes. What does it say? From Manawi, normally steam provided.
Yes.
Okay, what does it say?
Acidified solutions of 1 mole per dm of potassium 7.
1 mole per acidified solutions of what?
1 mole per dm cubed potassium 7. Manganese sulfate.
And what?
Manganese sulfate.
Manganese sulfate. What is the formula? Sulfate or sulfide?
Sulfate.
Sulfate. SO4.
Yeah.
Could this be the formula? Okay. And then?
Potassium dichromate.
And potassium dichromate, yes.
And chromium sulfate.
Okay. Guys, what is, do you know how to assign the charge here? It's potassium manganate, how much? Manganate 7.
Yes.
What is the charge of manganese? 7. But this is not the formula. But you're saying manganese, how much? Sulfate. This is a transition. Manganese to so manganese 2 sulfate, then it's all. And it, well, I'm not from a formula. So I remember a formula. Dichromate ion, CR2 here. Remember the booklet. Any charge of G. Dichromate ion. Anyway, just give me the formula.
KMnO4.